All right, so now we're going to talk about chapter 6. If you're looking in the book, we're not covering all of chapter 6. We're only going to cover a little portion or section of chapter 6. So we're going to talk about those orbitals and what happens when those orbitals come together. So we're going to talk about orbital hybridization. So before, when we talked about the orbitals, we said we have an S, a P, and a D, and an F orbital, but that was for one element. But now if this element and this element come together, those orbitals are going to end up overlapping. And so when they overlap, we're going to get a combined kind of hybrid orbital. So my hybrid orbitals result from overlap, which comes from bonding. So when I bond, I'm going to have overlap, and that overlap is with more than one orbital. So more than one orbital is going to come together and it's going to overlap, okay? And we're talking about the orbitals of the central atom. So we're not worried about the other atoms in my molecule. We're just talking about the orbitals of the central atom and then those orbitals that are coming from the atoms attached to the central atom. So we want to think about my valence orbitals. So let's think about what available orbitals there are for that central atom, and let's put them in order. So when we think about orbitals, what's the very first orbital we hit when we look at our periodic table? So the first one is in this block. That's the first one we hit is this block, and that was our what? That was our S orbital. And how many different S orbitals did we have? We only had one. What was the next one? So we would go here, then we'd come over here, and this was what block? This was my P block. How many different P orbitals did I have? I had three. I had three different P orbitals. Then the next, we do S, then we would do P, then we would get to D. And how many different D orbitals were there? There were 5. Okay? So 5 different orbitals. So I could have an S, 3 different P's, and 5 different D's that could all be mixing together to make this new orbital shape. So let's think about how we do this. So this is kind of like an example. So how is it all going to come together? So say, for example, my central atom has 3 different electron groups. So it has 3 different regions of electrons, 3 different electron groups. So that means that I have to take 3 different atomic orbitals and now hybridize them. I have to mix them and make a hybrid. So if I have 3 different atomic orbitals, I have to think about what are those 3 orbitals going to be. So I start with the beginning. I need 3. So if I start here, this would be 1, 2, and 3. So I'd have an S orbital, a P orbital, and another P orbital, because this is the order that I would go in. So if I have to make 3 different atomic orbitals and hybridize it, I have an S orbital, a P orbital, and another P orbital. That's the 3 individual atomic orbitals I have. Okay? And it's 3 because there was 3 electron groups. So I have 3. But now these have to kind of go together. I have to mush them together and hybridize. So what happens is when we mush it together, we say, what's an sp2? This is going to be one orbital that we call an sp2 because it has the characteristics of an s orbital and the characteristics of 2 p orbitals. So I would take these orbitals, push them together, mix it up, and this would be the one that I get. So what we do is we look at the number of electron groups on our central atom, and based on those number of electron groups, we can then decide what is my hybridizations. So on the next lecture, we're going to start talking about all the different hybridizations.